Today we are talking about shape, center, and spread. So you got three possible shapes. You probably need to trace them because they didn't copy very well. This one is called symmetric. What does it mean for something to be symmetric? Same on both sides, okay? So that one is symmetric, and you probably need to trace this other one. This one is called skewed left because the tail is on the left. Wherever the tail is what it's called. Okay, so that one's skewed left. And then this one down here is called skewed right. Where is the tail? On the right. Okay? All right. 3 ways to talk about, or 2 ways we'll review today. For the center, the mean is the average. You need to fill that in. Mean is the average. What is the calculator symbol for average? Good. Excellent line above it. Write that down, please. If I write it, you should write it. The median is the... Okay. All right. Median is the middle. The mean is more affected by an outlier. Does anybody remember what an outlier is? Yeah, it's like let's say pretty much everybody in this class made like a 70, 75 on the quiz, and then somebody made 100. That 100 would be the outlier, okay? The average is more effective because how do you find an average? What do? You add all the numbers up and then you divide. So if you have somebody who makes 100, they're going to pull the class average up. It's not really going to affect the median. The median is just the number in the middle. Does it matter what the highest or lowest number is for what's in the middle? No. It's just whatever's in the middle. Okay? All right. And then the next part we have is spread. All right. And for that, what does it say? Somebody read the first part for me. For spread, what does it say? It says range. What is range? How do you find range? Anybody remember? Max minus min. When it just says the word range, that's max minus min. Okay? Now, IQR is what? There you go. Q3 minus Q1. So you got to know the difference. When it says range, that's just max minus min. Okay? Standard deviation is how far each data point deviates from the mean. So it's how spread out the data is. The more widespread the data, the bigger the standard deviation. Okay? So the more spread out it is, the higher standard deviation you're going to have. Okay? What about the less spread the data? The smaller the standard deviation. Okay? All right, what do you think about this one? The smaller the standard deviation, the less or more variability? Less, okay? So if they're less spread out, that means you have less variety, okay? And then the last one, the larger the standard deviation, the more variability, the more variety there is in the data. Okay? Okay, here we go. These are called normal curves. All right, but you don't have to necessarily know that. You'll do more of it in Math 3. But anyways, this says what is the mean of graph A? Whenever I see the word mean, I should think average. So what is the average of graph A? Well, you're just estimating. What do you estimate it to be at? 42. 42? Okay. The average is where it balances itself out. So the balance point is at 42. What about the balance point for B? 32. What did you say? I said about 32. 32? Sure. Okay. Which graph has the larger standard deviation? B. Okay? Standard deviation is how spread out it is. Which one's more spread out, A or B? B. So spread out standard deviation. Okay? All right. What would happen if we added the number 30? So pretend there's a whole list of numbers that you had before you graphed it. If we added the number 30, what would happen to the mean? It would stay about the same. What did we already say it was about? 30. Okay, so nothing is really going to happen. Okay? What about if you add, what if somebody made a test score of 20? What would that happen to the mean? It would bring it down. Okay, it would bring it down. Okay, because 20 is a lot smaller than 32. Okay? All right, what about if somebody made a 48? Up. It would bring that mean up, bring the average up. What about 12? Down. Bring it down. Okay? All right, what would happen to the standard deviation of graph B if we added 30? So we're still looking at graph B. What is standard deviation? What should we think about when we see that word? How spread out it is. If you added the number 30, would it spread it out more? No. So again, nothing would happen. Okay? What about if you added 32? Nothing. Okay. 47? Yeah, it would spread it out a little bit more. So it spread it out more. All right, be really careful. What about if I added the number 15? It would spread how? It would spread wider. So does the standard deviation go up or down? Up. Okay, let me say that again. Okay? If you add a number 15, will it spread it out a little more? Yes, standard deviation is how spread out it is. So even though you're adding a small number, the standard deviation goes up. Okay? All right, and last question. What would happen to the range of graph B if we added 30? Okay? When I see the word range, what should I think? Max minus min. Sorry, I just kind of misspelled that. So, the range is only affected by the maximum or minimum. Is 30 the max or the min? No. So what would happen to the range? What would happen to the range if you added the number 30? Nothing, because you haven't affected the max or the min, so nothing would happen. What about 15? Nothing. Okay, because 15 is not the max or the min. What about 49? Okay, somebody who hasn't answered. What about 55? Nothing. It's going to make it go up. Because look, is 55 on the graph? No. So 55 is your new what? Max. So that's going to make the range increase. Okay? What about 6? It's your new minimum. Very good. It would still make the range go up. Okay? So right now, I should draw this better, but let's say this just stops at 50, just to make it easy. So what is 50 minus 10? 40. So the range on this graph is 40. If you now make it go to 6, if you go to 6, what is 50 minus 6? 44. What happened to the range? It went up. Okay. All right. Kyle's test scores are as follows. If he makes a 98 on his next test, which of the following would be true?
I actually have a question.
Yeah.
If a graph had like a steeper middle section, but it still went pretty much across the graph, would it be like the same standard deviation as like one that's almost like not so steep and
You'd have to have actual data points because you're right. Those two are very similar situations. I was trying to think about more at lunch, but I don't think they could ask you that. I think you'd have to have the actual data. Okay. Okay. So if he makes a 98 on his next test, which of the following would be true? The mean decreases, the range increases, the standard deviation decreases, and the interquartile range decreases. How can I do this problem? Stat. Okay, let's do that. Don't put in the 98. Don't put in the 98. Guys, let's go. Put them in. Type them all in L1. Let's go. Start typing, please. You're typing them all in L1. Guys, make sure you have it typed in. Okay, after I get it in stat, I'm gonna hit stat again, go over to calc, and I'm choosing the first one, okay? Hey, I need y'all to stop talking. I'm gonna go ahead and write down the things I need on here. So the mean, what's the calculator say the mean is? Thank you, 89.875. All right, and you could round that. The range, I need to scroll down. The range is gonna be the max minus the min. Somebody do that for us, 103 minus 76. Thank you, 27. All right, guys, the standard deviation, this is new. It's the SX in the calculator. It's the SX. So scroll back up if you need to. So it is 8. And then how do I get the interquartile range? Good, Q3 minus Q1, so 94 minus 85.5. Somebody do that for us. What is it? 8.5. Okay. Okay, now go back to stat. It's really not as hard as it seems. Go back to stat. Do you have to type them all in again? No, what do you have to do? Add 98 to the bottom. So you add 98, press enter, stat, calc. Oops, I went too far. It's the first one. All right, did the mean decrease? No, what did it do? Increased, okay? The range, max minus min, 103 minus 76, did those numbers change at all? Stayed the same. Standard deviation is now 7.9. Did it decrease? Yes, so the answer is C. Okay. All right, Miss Patterson's bowling scores for the past month are the following. If she scores the following 4 scores on her games that weekend, what can be said about the data? This one's asking about the peak and the spread. You can use the calculator if you want, but I prefer not to use it for this one. You need to put the numbers in order. You need to put the numbers in order. What's the first? And we're gonna ignore those 4 for now. So what's the smallest right here? All right, 170, then what? And then, write this down, guys. 197, 200, 205, and 226. Okay, now I'm going to take her 4 new scores and just kind of put a star where they go. So 241 would go at the end. Y'all agree with that? All right, 198 would go in here. 162 would go here. And 230 would go at the end. So I'm just putting stars where they go. Okay? All right, if you add those stars, does it spread it out more? Yes. What about the peak? The peak is in the middle. Did that become more? No. Yes, because you added a number to the middle. So it became more peaked and more widely spread. So the answer is B. Okay. All right. Which set of data would you expect to have the greatest standard deviation? Somebody tell me what you're supposed to think of when you see that word. Spread. Okay. So, which data would have the greatest spread? Okay. Another thing you can think is variety. Okay. Which one would have the greatest spread or variety? Okay. What about the heights of all first graders? Well, we'll just read them all. The heights of all first grade teachers, the heights of all first grade students and teachers, their circumference of wrist, or the foot lengths of all the teachers in your school. Which one would be the most spread out? The students and the teachers. First grade students are going to be really short. Their teachers are going to be a lot taller than them. So that's going to make it spread out. Okay? All right, what about this one? We kind of saw this question yesterday. Which manufacturer has the greatest variability? Adam. Why? Why is Adam's the greatest? It's the most what? Spread out. It's the most spread out. Okay? All right, the table below shows the population of several cities. What would happen if a population of 50,000 was added to the data? Okay? Guys, before putting it in stat, you could always think about it to see if you could save yourself having to type it in. What do you notice about 50,000 and all these numbers? It's bigger than all of them. Do you see that? 50,000 is bigger than all the ones in the table. So if you add 50,000, the standard deviation should increase. It should spread out more. Okay? Let's get B for now. If you add 50,000, would the range decrease or increase? Increase, because you now have a higher maximum, a higher number. Okay, so it can't be C. Okay? What about the mean? What's the mean? The average. Would the average increase if you add a big number? Yes. Yeah, so the answer is D. Okay? Can you put it in stat if you want to? Sure. Okay? All right, the choices below are data sets, and the choices, guys, W is a constant. Each choice has the same mean. Which choice has the greatest standard deviation? Okay? What does it mean by W is a constant? It doesn't change. W is the same number. Okay? If you wanted to, you could pick a number for W. Okay? Let's do that. Pick a number for W. 2. Okay, I heard 2. What would that make this number? 0? What would this one be? 1, 2, 3, and 5. Okay. Oh, sorry. Oh, all right. So if you wanted to, you could pick a number. Let's go ahead and jump to D. If W is 2, what is this one going to be? -1, 2, 2, 2, and that one would be 5. Okay? And you notice that this one's W minus 2. We already did that. That's 0. This one's -1. What about here? This is 4. What is this one? 5. Okay? I'm looking for the greatest standard deviation. What am I looking for? The biggest spread. Which one's most spread out?
C.
Ooh. Okay, so you can at least narrow it down to what? C and D. And you are correct. C is more spread, but why? They both go from -1 to 5.
C has like greater variety.
Very good. Good. Greater standard deviation means bigger spread and more variety. These numbers are all 2s. What are these numbers? 1, 2, and 3. So that one has more variety as well. So it's going to increase the standard deviation. Okay? All right. 13. If the weight of the polar bear is removed, which statement is true? Okay? How much does the polar bear weigh? Okay. What can you tell me about the polar bear? Since he weighs 1,000, what do you notice? It's the max. He's the biggest bear. Okay? If you remove him, should the mean decrease? Okay, so the mean should decrease. Oh, they all say that. Okay? Will the mean decrease more than the median? Yep. Okay, so I don't know if you remember at the very beginning, the mean is more affected by an outlier. So the mean is going to decrease more than the median because the polar bear is a high outlier. That is a perfectly correct statement, okay? Now, if that doesn't make any sense to you, you can put all these numbers in what? Stat, and find the mean, find the median, okay? And you would have to write those numbers down. Then you would have to take out the 1,000, delete it, and then figure out what the mean is and the median. Could you do it that way? Yes. Okay. All right, 14, match each data set with the appropriate description. Okay. Have they already put the numbers in order for us? Here's your numbers right here. Here are your 3 sets. Are they in order? Yeah, so that's pretty nice. Okay. Symmetric means that it's going to be the same, about the same on both sides. So which one is about the same on both sides? Okay, let's focus for a minute. What about this one? What do you observe about this one? Okay, 10, 10, 10, 10, 10, then what? 60. What do you know about 115? It's the outlier. Good, very good. You might want to write that down, okay? 115 is the outlier, okay? All right, let's look at the next one right here. 15, 75, 85, 95, 105, 115. What do you notice about this one? 15 is the outlier. Very good. 15 is the outlier. It's much smaller than all the others. Do you see that? Okay. What about this last one? 15, 25, 35, 45, 55, 65. They're all plus 10, right? They're all the same. They're all constant. Okay. So which one is symmetric? The last one. So that one is symmetric. Okay. That one's symmetric. Which one is skewed left? The one with the 115 outlier or the one with the 15 outlier? 15. The 15. It's on the left. Okay? It's on the left. So it is skewed left. Okay? And this one is skewed right. Why? The outlier is on the right. Okay? All right, last one, 15. The number of goals Jackson scored this season are shown below. What is the best description of this data? Is it symmetric, skewed left, skewed right, or uniform? Let's look at it. 0, 3, 0, 2, 5, 1, 0, 1, 0, 2, 4, 0. Very good. Very good. I would definitely want to put it in order. Okay? So 0, 0, 0, 1, 2, 3, 4, 5. Okay? Then there are 2 1s, a 2, a 3. Oops. How many 2s are there? 2. Then a 3. Just 1 3? Okay. Okay, is it symmetrical? Yeah. We're gonna learn this tomorrow, but if I say this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5, I can make a histogram. This is the frequency. It's the number of times that you have one. So how many zeros do I have? 1, 2, 3, 4, 5. How many ones do I have? 2. How many 2s? Okay. How many 3s? And 4 and 5, 1. If you drew this, what do you see now? Skewed right. Okay. All right, let me show you one more thing. If you go to Desmos, and I click here, then I click this keyboard down here. Do y'all see the keyboard down here? Yeah. Click functions, and you click distribution, and then I'm gonna click histogram. And I'm gonna type in the number 0, 0, 0, 0, 1, 1, 2, 2, 3, 4, 5. What? Oh! Oh, y'all are so good. Okay. Now. Oh, it's there. Oh, and then maybe put a 1 there. No. Points can. I don't know. I'll have to look at it at lunch. I did this the other day, and I did a box plot. 0, 0, 0, 0, 1, 1, 2, 2, 3, 4, 5. Oh, and you had to put brackets in.